Hi, everyone. Good morning and good evening, wherever from the world you're joining us. This is our Hangout on Air session called Best Practices for a Great Sign-In Experience with Stephen Soneff. Hi, everyone. Good morning and good evening, wherever. Stephen is product manager for Google's developer APIs for authentication on Android, including Google Sign-In and SmartLock for passwords. He previously worked as an engineer on Android apps at Google, did Android development at several startup companies, and wrote the original Facebook Android SDK launched in 2010. With that, over to you, Stephen.
Okay, thank you very much. So yes, as noted, my name's Stephen. We do have one other person from my team, Dev, who may or may not be able to join towards the end for some questions on some of the different technologies we'll cover today. But the general idea here is thinking about how to make sign in and sign up easier in all of the apps and websites that are out there, whether you're building that yourself, you're building it for one of your customers, or you're trying to augment or improve a system that already exists. So this is material that we've shown at a variety of other events and venues like Google I/O. If you're actually interested in getting these slides yourself, you can just do a quick internet search for Google Identity Internet Research, and you'll find the top link there, Google Sites page, which will have links to slides on this material and a lot more. And we can certainly circulate it around. My contact info is also there. It's just sso@google.com if you ever need to reach me. So we'll dive into it here, and there's a fair bit of material covering different use cases, which I'll try to explain. And with the contact info here, you can always follow up with us to get more information. Okay, so I think the real place to start is to think about why it is that we should really be thinking carefully about things like the authentication user experience. And it really starts at a point like this, that someone will encounter a new service, maybe one that they've never used before or can't remember if they've used. And often it looks like this. Downloading a new app or going to a website for the first time will show you some sort of splash screen. And the first step, the first thing that someone needs to do is to sign in or sign up. And if you've done this before, of course everyone has, you'll realize pretty quickly that it's not the most pleasant experience. You have to type a lot of information, which is pretty painful on mobile. You have to create new passwords and so on if it's a legacy authentication with username and password. And so what we'll do here is we'll just pretend we're an ordinary user and go through and see what goes wrong, essentially. So let's walk through the experience of someone named Alex. And so Alex comes along and she types in her email address and creates a brand new password for this food app. And even at this point, I think she's gotten farther than a lot of other people would have. When they start and download that app and don't know what this service is about, oftentimes people will even abandon right up front and wonder what this service is, why they have to sign up. And certainly creating a new and strong, unique password is pretty painful. And so what we're going to do here is we're going to keep track of how many times Alex has to enter that, that long and hopefully strong and unique password. And we'll keep track of that with these little ducks that you see on the right there. So we're up to 2 so far. So signing up requires entering, a password often twice. Many times the pattern of asking for a password and repeating it has been inherited from desktop web, where typos are common, and making sure that it's the same password is important. But of course, it's very difficult for someone to even do this right in the first place. The passwords are often masked, as you see, and getting them to be the same is pretty challenging. So this is not a fun experience, but let's see where it goes. And so, of course, if you've done this before, you've often seen a message like this, that people will actually have a hard time remembering whether they've even signed up for these services. They might have signed up in another place and not remember. And so in Alex's case, it looks like there's an account that already exists. So of course, what does the ordinary person do in this case? Well, they go back and they try the sign-in screen this time. Same thing, and we'll provide this type of functionality to their customers would be coming to you to ask if, hey, could we build or have a system like this that works well and is a lot lower cost or effort to implement. And so I think that's probably what you're thinking about here is how to build a system like this that hopefully works better, in fact, for your customers, and wondering what technologies are out there that could make this easier. So that's what we'll cover today. Is Google offers a suite of things depending on the nature of the customer, the user base, the scenario, and the platform, and so on. And so we'll show a little bit about these three technologies, and I'll hopefully highlight a couple of cases where each one is useful. Okay, so let's start off and think about what to do about that password problem specifically. So of course, not only is it that people struggle with passwords, but when they do have to create one, they're often creating really weak and reused passwords across all of their services. And the reason for this, if you go out and ask someone, is not necessarily that people don't know that this is a bad choice for their password, but that password creation and input is really a point of friction. That when people are creating an account, they just want to use that service. They just want to use the food app that we saw. And to get through that login screen, often what they'll do is they'll enter an easy to type password like this, just to get in and get through. But then of course the problem is that they never update it again later when they become a dedicated user. And then sooner or later the bad guy tries to get into their account and steal their data. And with the weak and reused passwords, it's almost trivial. Okay, so what can we do? And so that's what I want to illustrate here with the first one that I think has pretty good adoption and awareness already, and that is that you can sign in without a password to all kinds of apps and websites using Google Sign-In. And so to illustrate this, we can take a look. There's a little bit of history here that I want to talk about first, and that is that this has often been kind of known by the moniker of social sign-in. So in the past, there's Facebook and Google and Twitter are all login mechanisms that the user could go with to create a profile or create an account with a service. And of course, Google did have one of these as well, Google Plus sign-in. And it's a screenshot here of the, as we call it, consent screen, the screen that a user would see and agree to share certain information, such as their contacts and so on. And in reality, we found that this never really was all that successful, both in terms of people having Google Plus accounts or sharing the data. There was a lot of decline and drop off at a screen like this. And so what we really want to emphasize here is that you may know the experience of putting a Google sign-in button, but I really want to emphasize that Google sign-in today is really simplified and streamlined. That the branding is pure Google. There is no social aspect to it. You don't need a Google Plus account, and that the information that is shared is only the user's basic profile information, as we call it. And basic profile information includes exactly what's shown in the UI here, the person's first and last name, and then a profile photo. And that's the only information that's shared. And so in fact, if you look at a flow, complete flow in context here, you have that nice Google branding, so it gives a user a non-social option, essentially, which sees excellent usage, especially on Android, where people will all have a Google account to use the Play Store, and quite good usage on the web and iOS as well, especially in markets where there's a lot of Gmail users and so on. So in selecting that Google option, you're presented with this chooser of the account. So of course, if user has multiple accounts active on this device, they could choose between them. So for example, work or personal. And on that note, it also supports things like the G Suite accounts, the corporate accounts that are based on Google identity. So you have a really nice comprehensive option here for a lot of users on the platform. And with a one tap on that entry in the list, the user's in with that basic profile information. And so, of course, that's a nice experience for Android. It's the same across the web and iOS. So Google Sign-In, of course, works on all of those major platforms. And in fact, you can implement Google Sign-In with standard OAuth protocols anywhere, essentially, on TVs, embedded devices, and so on. So it really is a pretty comprehensive solution that goes across all platforms and provides a really nice user experience. noting a couple of the technical aspects of how this works. So how is it that Google Sign-In provides a passwordless authentication mechanism? And the idea behind passwordless auth is the concept of tokens. And so we call these tokens representing the user's identity an ID token. And an ID token is a little JSON web dictionary, as you see here. So it's got a couple of fields: the name, the email address, the photo, and so on. And it's been signed by Google. So it's been signed with our private key. And then you, as a developer or as the system integrator, whichever backend service that you're integrating with, can take one of these tokens, validate it, and then return the user's signed in info at that point. Okay, so we'll talk about this in just a second here. And if you've done integrations with Google in the past, I just wanted to highlight how this had worked previous versions, such as Google Plus Sign-In. So the calling app here, the app that users would be interacting with, calls the sign-in method to talk to Google. Google shows some UI, whether that's a redirect on the web or some UI shown by Play services on Android. The user interacts and says, yes, I'm okay providing my identity information to this app that I'm interacting with. And then an OAuth access token or code is returned to the app, sends that token or code to its application backend server. The server then uses the token to access a Google API through a REST call on the web to obtain the user's information. And then with that information coming from Google, the application can set up a session. So that's typically a cookie, something like that. So this is a pretty standard OAuth flow. And I just want to highlight that in these legacy SDKs, it did require a network dependency. The get info that you see there required the app's backend server talking to Google. And I just want to highlight that with the JSON web tokens, the newer tokens from Google Sign-In, that's actually not required anymore. So what happens is the ID token is self-contained and can be validated locally on the backend server with a cached or fetched public key to validate the signature on the JSON web token. And so if you are thinking about updating one of your clients' integrations from Google Plus to Google Sign-In, there is a little bit of a backend change here, but the value is quite high that without having to do a network call to Google servers, you reduce that network dependency and you're able to validate the tokens locally, which is much more performant. So you'll reduce the latency and any of the reliability issues you might have seen in contacting the REST APIs. Okay, so that's kind of a technical overview. So we've essentially offered the ability to log in with a token representing the user instead of having to validate a username and password. And many nice applications and utility of this in that you no longer have to validate people's email addresses or have them struggle with passwords. And we'll run through a couple of snippets of code here, but of course these slides are posted so you can reference them if you need to. It's essentially using, say, the Google Sign-In APIs in Play services, constructing a request to access the user's information, invoking that, showing the UI, and then when the interaction is complete, you'll obtain that ID token, as we discussed, and send it to the server to validate. Okay, and similar things that have to be done on the server, verifying the ID token and applying your business logic based on the user information, and doing similar type stuff across the web and the other platforms where a user might be trying to sign in. Okay, so with that, we'll move on to a couple of the other technologies. So it's certainly nice when we have a solution that allows people to move away from passwords, but we do have sort of a complementary product which allows the management of password-based accounts. So of course, realizing that not everybody can go with Google Sign-In, can do passwordless, whether that's as an app that has certain UX requirements or whether as a user who has certain preferences. So we do have a complementary product to manage password or legacy accounts. So let's take a look at that. So the point that I really want to illustrate with this product, SmartLock, is that adding a Google sign-in button or another login mechanism doesn't really solve the complete authentication problem. So, of course, in introducing a new button, in some ways it adds more complexity that people will have to remember which option they pressed, whether that was going with Google or Facebook last time, or whether they still had that legacy account email password, or whether in fact they have to recover an account or go through a sign-in, sign-up flow. And so there's still a variety of problems here. And what I want to illustrate is that we can do things better, especially on mobile, where typing is extremely painful. And so the concept here is that we would like to really mitigate a lot of the friction that is introduced by asking people to sign in, sign up. So it's all that terrible experience that we saw at the beginning. We want to eliminate that, mitigate it to the extent that we can with things like streamlined sign up, as you saw without passwords, with assistive things, with smart lock, as I'll show you here, and even sign people back in automatically. And so that's really was our thinking behind the smart lock product here. And it's pretty widely used, available on Android and Chrome at the moment, widely used in a couple of the top services, so you can check it out in Netflix, for example. But I'll walk through here how it works. The main idea, and really kind of the most beautiful experience you could get, is having somebody come back to one of either your customers' properties or the app that you're building yourself, whether that's on the web or on Android, and the user just be automatically signed in. So Ticketmaster, as an example here, is one of these services where they're entirely password-based, and I'm not sure whether they'd be able to technically or for whatever reasons include a passwordless option, but certainly all those users who have stored passwords with Google are automatically signed in when someone downloads the Ticketmaster app. And so how does this interaction work? And how does it work across platforms? Let's look at an example. So one of the apps that or verticals in general that finds this extremely useful is travel. So in the travel experience, you might be booking something on your phone here. HRS is a hotel booking app that I actually used for my own trip here at Google recently. And the idea is that you can log in on the phone, make a booking, save the password, and then come back either to the app again later, perhaps on another device or after installation, second installation or reinstallation, or come back to the website, and you'll actually be automatically signed in. So there's the ability to programmatically retrieve the user's information, programmatically store how they logged in, and then use that information to sign the user in automatically. Okay, so let's take a look at some example code there. Okay, so the idea is that to request the user's information in order to sign them in automatically without having to show the login screen, you'll construct one of these credential request objects. With a credential request, you specify what types of login information you support for the given property. So whether that's simply passwords or you can log people in with Google or Facebook, you say, I would like to know if the current user has used username, password, Google, or Facebook in the past. With this credential request, you pass it into the API that we provide in the Play Services SDK, and you expect a callback. The response will either tell you that this user has nothing stored, perhaps they're a new user or they've never saved any information, or that they have some information available. And that may be the username and password directly, in which case you can submit it to your server and set up a session for the user, or it's simply what we call hint, a type of credential that says who the user is in terms of their user ID, but that they have an account type based on Google or Facebook, and you'll need to obtain a token for that account type from the provider of that identity. So going to the Google or Facebook SDK to obtain a token for the given user. We'll take a closer look at that in a second. But the idea is that you can programmatically invoke this request API, for example, when the app starts, take that information, use it to sign the user in, even in the background behind a splash screen, without having to show the user a login screen. And so you can imagine how valuable that is to some of the partners that we've seen integrate this. Similar experience here on the web and Chrome with the credential management API, navigator.credentials, a standard-based API. So as I mentioned, partners have really been impressed and found this extremely useful. So we have, for example, in the partner publisher space, all kinds of newspapers, the New York Times, Guardian, Economist, and others in Europe that are signing people in automatically to their web and their Android properties. And the experience then is really improved, that someone can download the app, in screen, that blue bar appears, the user's content is immediately available, and at this point, they don't have to find or navigate to the login screen, struggle with a subscription or paywall. They simply see their content right away. And that's certainly very nice for a publisher property like a newspaper, but it's equally or maybe even more valuable for some of the retail, the travel, or the commerce partners that are out there. And so examples there would be, doing a flight search on your mobile device, saving that information now that you have an account for that service, and then coming back on the desktop site and being automatically signed in, immediately seeing your shopping basket or your itinerary and being able to check out with that information right away. Okay, so that's automatic sign-in, but as I alluded to, you have to save or have the user store some information about their account in order to get into that state. So let's take a look at the save experience. So the simplest thing, very similar to behavior you've seen in Chrome and on browsers for years, is offering to save a username and a password that the person has typed in here. You're in fact saving it with the Google account that's active on the device. If there are multiple accounts, you can select between them. But the idea is that in the same way that Chrome for years has been storing username and passwords for the websites that someone might visit, you can now do so programmatically on Android. And so that's taking all of these existing legacy email password users, remembering their login information, and then retrieving it as we described. But the nice thing about having a programmatic API here to do this is that you're not necessarily having to rely on any kind of heuristic-based email password login to detect and save the user's login information. This works with non-password logins. And so let's look at an example here in the New York Times where in selecting the Facebook option, I log into the New York Times app with Facebook, and I'm offered a save dialog that looks very similar to the password one. But if you look carefully, you see how there's a save account option. Now in saving this account, what we're remembering to the Google account is not just the username or password. There, in fact, is no password for this account. We're remembering that this user logged in with Facebook. And the experience then is that when I come back on a new device, and so that's what you see here on the right, the app will open, the blue bar appears, and the user is signed in automatically. And how that worked is that when the information was retrieved, we knew that this was a Facebook user, and we obtained a token for that user through the Facebook SDK. Okay, so let's go through an example of that just to illustrate how it works in a little bit of code here. You construct a credential object with either the username or password as you see at the top, or as I alluded to, you can remember that this person had a non-password based account. So for example, it could be with Google, Facebook, or even a phone number based account. You remember their username and the type of the account rather than the password, and then you call the save API. The save API then may require resolution in the case the user needs to see and interact with the save dialog. And so starting the result for resolution will hand control back over to Play Services to show that save UI. And then if it can be saved automatically, in the case of a password update or a Google sign-in, for example, it'll succeed right away. And so that information then is saved with the user's Google account if they allow that, or it can be saved automatically. And when the user comes back, you'll simply retrieve that information, use the username password to sign in, or obtain a token, so start a flow with Facebook or Google as though the user just clicked the button. And the same thing in Chrome here. Okay, so results here are also quite good, that Netflix has been saving, or at least initially started with a lot of passwords saved in Chrome. So there's an association process between the the Android apps and the websites that belong to the same service. And so in Netflix, having set up their smart lock integration, said that their website is associated to their app, and also offered to save passwords that the users type manually. And the end result there at their initial launch was pretty dramatic drop-off in ultimately the customer support inquiries that they had to field. And so, of course, what was happening here is that in users saving their username password and then having it retrieved automatically when the app starts after a new install or across devices, if user has multiple devices, they no longer had to type in or remember that password. And often, as is the case with Netflix being a paid service, users no longer had to figure out how to recover their account if they could not remember the password. So the result being that Netflix saw less inquiries to their support lines about their most common topic, which was, in fact, account recovery, users not remembering how they logged in, with what email address, or what the password was, or how to reset that password. So very valuable to a pretty major company like Netflix, and certainly any service with a large established user base, especially a paid service, would probably be quite interested in reducing the support contact volume and ensuring that people just land in their service without having to think about or struggle with getting signed in. Okay, so moving on to the kind of last point in the smart lock topic. We've thought about how to automatically sign in existing users and save the user's account information. You also have to think about how to bootstrap people's account creation in the first place. And so this is the idea of how to get people signed up. And we have a very useful dialog here that you see on the right, which is a system email selector. And so it allows the user to interact with the system with Play Services, select an active email address on the device, and in fact showing not just Google accounts here, as if you look carefully in the illustration, but also things like active non-Google addresses such as Hotmail or Yahoo. And with one tap, select that email address to use either for autofill purposes or perhaps even to sign people in without a password. And we'll show how that works in a second. So very useful concept here. It's worth looking at this kind of as a side-by-side thing for just the autofill purposes. So what we have here on the left is an assisted flow where the email selector dialog is invoked by AliExpress. You saw how it filled in the selected information, the name, first and last, email address, and even a photo if the user were to have one of those and the service needed it. And then you see how with that filled in information, the user is able to complete the flow very quickly without any errors or typos. And meanwhile, the other person who has to provide this manually, if you look at it on the right, is still going through the sign up process. So you can both dramatically reduce the amount of time, typing, and errors that users may see or encounter in this flow by using the email selector. Okay, and so to take a look at a little bit of the code behind that, email selection is powered by this hint request. If you just do a search for Play Services hint request, you'll find the documentation on this. And constructing a hint request starts with specifying what type of user identifying information you're looking for. And so you see how this example is set email address identifier supported as true. There is, in fact, also a phone number version of this dialog, so you could set it as set phone number identifier supported. If you, for example, were building an app that required the phone number as part of a registration flow, or perhaps it's a real-time or emerging market service where a phone number is, in fact, a primary identifier. So you can use this hint request to get a list of the device's phone numbers or email addresses. I should note that there's one very important aspect to this API. This is an Android API. And if you've built Android apps in the past, you might be aware of the permissions model that accessing things like the user's email addresses from the account manager or the phone number of the device required a device permission. But the idea is that with this dialog, Play Services, the system, is mediating the request. That layer on Android has the permission to read the email addresses and the phone numbers, and in the user selecting that, as we saw in the illustration a moment ago, that information is returned to the calling app without even needing a permission. And so that's a very, very important point to realize if you're an Android developer, is that you can obtain email address and phone number here mediated through a user interaction, but without requiring a device permission. Okay, so that's what happens here when you construct this hint request, obtain the intent, and send it off for resolution. The system is showing the dialog, letting the user interact, and only the selected entry is being returned to the calling app. And then in order to obtain the information that was selected by the user, you see in onActivity_result, you'll get a credential object back, the hint, and you can extract the various information, whether that was the phone number or email identifier. And in fact, in the case of an email address which is active on the device, an active Google account on Android, you'll obtain one other very useful piece of information, which you see at the bottom, which is the ID token. The same as Google sign-in, the identity token for a verified email address. And so in fact, you can put all of these pieces together to have a one-tap email selection in a verified form. You can skip all of the manual input that's needed, all of the typos and typing that is needed on a mobile phone, and you can even avoid having to have the user flip over to that email app by using this API. This is an extremely useful and powerful API on Android, especially in the new versions of Android where permissions are really cumbersome at runtime to ask for this type of user verification and identity. Okay, so if you're interested in that, reach out. This is one of the most useful things that we see among the SmartLock APIs. We have lots of data on this. So big companies like LinkedIn running experiments showing a meaningful uplift in the success rates of their sign-in and sign-up flows by filling in email addresses, names, and having verified email addresses. Super good value proposition here and return on the investment, because of course this work, as you saw there, can by and large be done purely client-side on Android. So it's just the Android developer, filling in portions of the form and perhaps even reusing your Google sign-in logic to consume the token for a validated email address. So for more information on this, we have the link here, g.co SmartLock case studies. And I invite you to go and take a look at that to learn more about the offerings in this space and the impact it's had on a lot of the large developers in the Android ecosystem. The one on the right here that I would really call out is that we've had some apps, especially in the travel space, where it's been tremendously successful, adding things like the email selector inline in their search results. WeGo was able to get 10 times as many people to create accounts for their service. So simply having a one-tap provide your email address for price alerts was extremely valuable. Okay, so with that, there's a couple of other technologies that we wanted to cover here that allow you to build authentication systems without having to do a lot of the plumbing and the infrastructure yourself. So what we've looked at so far in SmartLock and Google Sign-In are additions to existing login systems that can make things easier when there's an existing user database and existing users. But really building those systems from scratch is, as we alluded to, something that developers don't get super excited about. You spend day and night making them work and then have to keep them up and running and secure and so on. And so what we want to talk about in this section is some stuff about Firebase. And so the things that are really impede people creating good authentication systems and make them expensive are things like setting up the backend services, handling the user credentials securely, setting up sessions and managing those, and then using the user's identity information and authorization to access resources that might be specific to the user. And so that all is offered as part of a complete service in the form of Firebase. And so this is really geared towards new integrations, so services that you're setting up brand new for a new customer, for a startup, and they don't have the existing legacy user base to deal with. They're starting from scratch. There is unfortunately not an ideal migration path for Firebase yet, though it's something we happy to chat about. Okay, so taking a closer look here at Firebase Auth, Firebase is built on top of Google's infrastructure, so you kind of get the scalability and support that you'd expect from any of Google's cloud services. It's pretty comprehensive in what it offers, from Google and Facebook through to other OAuth-based integrations, email password, and even this year we've added phone number support as sort of the migration path for the Digits customers from Twitter, which we picked up as an acquisition this year. And it also comes with a very nice backend database management tools, so a console here where you can simply enable these different types of options. And then when the user comes to the client applications, you simply invoke these wrapper APIs to do things like create username password accounts, invoke Google or Facebook sign-in, and so on. Okay, so let's take a look here at an example of one of the flows with Firebase. This is the phone number stuff that we offered recently. So a user would start an interaction where you'd invoke some API to trigger, for example, SMS-based verification. The underlying APIs and SDKs on Android help you retrieve that SMS and then send that up to the server to complete the verification process. And then the end result here is a token then that you can use to validate your user. So invoking these APIs on Android looks like this, with verify phone number methods in the Facebook or Firebase SDKs. Same thing applying for any of the other login methods like Google and Facebook and so on. Once the user has been created, you'll see them in the console that I mentioned, where you can manage those users, do things like administer accounts, delete them, create new ones, and so on. So lots of useful things that you can do to get the user's account created. But of course, the real beauty in this is that it works beautifully with the other Firebase services. So once you know this user, you have this token representing the user, also a signed JSON web token. You can pass that into other authenticated Firebase services, like the database, for example. And in this way, ensure that users are accessing authenticated resources such as their own photos or chat history or whatever your application specific logic might be, in a manner where the user's identity has been verified and they're only accessing the resources they should have access to. Okay, so those are a couple of the services, the file storage, database, and there's a few more coming that work smoothly with Firebase Auth. So to sum it up, it's a managed backend service. It's got the different sign-in methods that I illustrated, SDKs on all the major platforms for you to build your applications, server SDKs to handle and validate those tokens, and then a console to set up, provision, and manage users. And we've had pretty good success with this. Lots of up-and-coming companies like Malang in Korea making use of this, Quaver, and really just saving them a lot of time and effort and energy in building their services. And certainly if you're, say, an agency or a vendor building services for other developers, you could simply take the Firebase solution, white label it. It doesn't require any special UI. You can completely customize it, and you'll have a hosted backend solution for your customers, so they don't have to worry about building that or maintaining it themselves. Okay, so that's a pretty nice solution in terms of the infrastructure. We often do have people ask, well, how is it then that some developer of the application would provide UI on top of these headless APIs? And that's what we also want to talk about here, is that it's not necessarily simple to build this type of UI flows on top of even a prepackaged set of APIs like Firebase. And so to illustrate the problem here in terms of building the UI necessary, I'll just walk through kind of the steps. So the first would be having a traditional login screen, maybe that's email, password. You have to also provide account creation, of course, so you have to make a decision based on email address, potentially, to avoid that sign in, sign up confusion. With passwords, you have to add things like password recovery flows. And then, of course, you want to let people sign in without passwords. That means Google sign in, offer Facebook as well. You have to be able to then do the very tricky work of disambiguating between multiple accounts that could belong to the same user, so same email address in Google and Facebook and email password. If somebody shows up with one of these alternative login methods, you have to do some linking. And so you see at this point, it's starting to get complicated. We can't even really read the diagram there. And then on top of that, you might want to apply some of the smart lock magic that we talked about, saving passwords, automatic sign-in, email autofill. And so at this point, it's getting fairly complicated. And of course, the real trick here is that if you're building a cross-platform solution, you're going to have to do it a couple more times for Android, iOS, and the web. And on top of that, you have to also maintain it, which is a fair bit of work as well. So what we really want to illustrate, and because we built this example UI for Firebase, is that this is a pretty substantial commitment of time and effort, either on the behalf of your agency or your customer, or as the application developer yourself. It's probably in the order of tens of thousands of lines of code. And taking this pre-built material that we've got for Firebase, the backend systems, the SDKs on the client, and then a full pre-built UI on top of it, you can really cut that down pretty dramatically. That on each of the major platforms, it's only a handful of lines of code to use the SDKs that we provide and the methods that generate pre-built UI to add an authentication system to an existing service. Okay, so I think we're a little short on time, so we'll skip the demo here. But if you're interested in the Firebase UI, there's GitHub links here, and we're missing the web one, but it's the same pattern. You can just substitute in web, and to take a look at all of the open source UI, you can take it, fork it, change it if you'd like to style the UI differently. But if you do it within a few constraints, you'll pick up updates pretty easily. And in this way, you have a fully hosted authentication system for you or your customers, along with all the UI. Okay, so to kind of just sum it up here in the last 5 minutes before we take some questions, the technologies that we've talked about today are things like taking an existing application that is perhaps username, password, perhaps it had some other login mechanisms, but allowing people to sign in with their Google identities. So that's all the Gmail users, the bulk of users on Android, offering them a passwordless token-based login mechanism. Get them out of the password business and into a world where it's one-tap sign-up across all the platforms they may use. Is super secure, backed by the Google user's account and the validations we do to sign users in, all the machine learning and intelligence that we apply to checking Google user account state can be leveraged by getting a user to sign in with Google. So that's proven quite successful, and you see Google sign-in buttons all across the web and apps. Certainly a pretty strong one to consider to get people out of the password business. That said, if you still have legacy users or specific requirements that don't support a passwordless or a login flow like Google sign-in, you can still use the password management APIs to programmatically save and retrieve user login information. And so as I showed in a couple of the examples there, that's things like remembering the username and password that somebody used. It also involves remembering essentially which button people pressed, and then when the user comes back, simply signing them in automatically with that information. So submitting the username password in the background, setting up a session, or triggering a flow with Google or Facebook SDKs to obtain the token for the user. And again, simply showing them all of the relevant content as soon as the app or the website opens or loads. And on top of that, thinking about how to sign up the new users as well with things like the email selector, phone number selector. And as one of the new APIs that I should have mentioned earlier, the ability to get both a verified email address and a verified phone number out of those flows through things like SMS verification and automatic retrieval. So there's a lot of utility here to existing applications in the form of Google Sign-In and Smart Lock. But as I mentioned, if you're working with a customer or building a brand new app yourself that doesn't have an existing system that you need to support and you don't have existing users, simply going to Firebase directly to get a complete off-the-shelf authentication solution, which manages the backend, provides UI, and even includes all of the options like Google Sign-In, phone number authentication, and Smart Lock that you would probably love to see, but don't necessarily want to build out yourself. And new with that was the recent addition of the UI versions, the pre-built UI. So pretty comprehensive set of solutions. I'll leave it here with a couple of links to more information. So if you'd like to hear more about the general Google identity services, so that's Sign-In and Smart Lock, check out developers.google.com/identity. Firebase stuff is linked to there as well, but you can also go directly to the Firebase documentation. Firebase, of course, lives as one of several different technologies to help build applications. So things like crash reporting, notifications, analytics, and databases, and so on are all part of the Firebase suite. And for any of those services that you need an authenticated user, Firebase Auth, either taking this hosted managed solution with UI or bringing and plugging in your own auth system is the way to go. And yes, the link there for the UI is all available, including the web. So check those out. And for updates and things like that, you can check any of the social media channels, whether that's YouTube, Google+, and so on. So I think we will probably stop it there and take a few questions with the last 10 minutes. I'll leave this slide up with the links to more information for you to copy or take a screenshot of or whatever you'd like. And we're always happy to take questions by email as well. I mentioned my email address is sso@google.com. Okay, so from there, did we want to open it up to questions?
Yeah, absolutely. Also, thank you so much, Stephen. We did lose connectivity for about a minute towards the start of the presentation. So if you have time, do you think you could recap a couple of slides for us? Basically, the slide where you have the sign-up page with the 2 ducks till the page where you talk about the 72% of developers and their experience with signing on. So do you think you could recap a couple of slides for us while our viewers have some time to formulate their questions?
Sure.
Thank you.
So the introduction slides here were just illustrating the problems that people have in creating accounts. So it's things like having to remember whether you have an account, typing in passwords. The ducks there were just counting how many times a password has to be entered. So things like accounts already existing are a major problem, then going to sign in, not remembering the password, having to recover, to go to password reset flows that never get into the inbox, end up in spam, clicking on that link, setting a new password, typing it all over again with repeated masked password fields, finally being signed in, but then realizing it was the mobile website that was signed in, going to the native app and doing it for a 7th time. So it's just really a painful thing that nobody likes to do. That was the main point of the introduction. And not only is it that people hate doing this, but developers aren't necessarily thinking about this, even though it might be the first screen in their app. And then so leading to this point where hopefully the video came back that basically 72% of the developers in the study that we did for Firebase were really just not happy with what they currently had. So the majority of people didn't like what they currently had, and they certainly weren't happy with the effort they had to put into it to make it work and to build it. And so I think there's a real opportunity here to either make this easier or provide a very valuable service to your customers. And so that was the
yeah. All right, thank you so much, Stephen. I don't know if you're on the YouTube page, but we do have one question from Arun Sasidharan. If I want to send an access token to my server so it can upload content to YouTube, how does Firebase help with that?
Yeah. Okay, so Firebase can help you do the authentication flows or the authorization flows, as you described, for things like Google or Facebook. So we'll have to give you a pointer to the exact documentation, but the concept would be that in doing an authentication flow with Google or Facebook, where you ask the user for permission to, for example, post the YouTube comments, the user would see a screen that grants your application that access. The client application would obtain an OAuth2 authentication code, which is then sent to the server, exchanged for an access token. So the exact mechanisms and how you'd invoke that from Firebase, we'll have to get a pointer for you, unless Dev happens to be on the call yet and can answer that. Dev is our Firebase specialist, but we'll get your contact info and follow up with you.
Perfect. Thank you, Stephen. I have another question for you from Chetan Sachdeva. It says, what if I uninstall the app and reset my phone? Would the smart lock still show me the email password I used? Is there a way to erase that if needed?
Right. So to the question about smart lock here, yes, the information is stored with the user's Google account and available across devices and in cross installs. So that, like in the New York Times example, where if I had saved that I had used Facebook or saved my username password, it would be available and available automatically if desired on the next device. That said, if you do have an application where you would like to support the user perhaps using a different account on the second device, what you can do is instead of immediately signing the user in with that information, you can in fact disable the automatic sign-in or give the user some UI that allows them to switch accounts, use another account, perhaps save that information so that they have an easy switching mechanism in the future. And probably even the more common case is that when the user signs out, you simply want to make sure that they have the option to use another account or stay signed out instead of being automatically signed in. So yep, take a look at the documentation for Smart Lock. This is described under the disable automatic sign-in or handling sign-out scenarios.
Perfect, thank you. I don't see any more questions here. If you do have questions, you have a couple of minutes to ask Stephen. All right. I guess we have no more questions, Stephen.
Okay, well, if you do ever need anything, as I mentioned, I'm sso@google.com. You're welcome to contact me. And Dev here is our Firebase specialist, so he can also help answer questions. We'd love to see what types of applications you build on top of some of these technologies. As I mentioned, things like our Smart Lock case studies are available on the web, that just g.co, Smart Lock case studies. And if you do build an app that sees good usage of some of these technologies and they are really helpful in terms of business impact, we would love to hear about it and include the apps that you work on in this growing list. It's pretty popular in the Android ecosystem, and we're even looking at some newer things for the web coming soon to bring some of this smart lock style functionality, such as one-tap sign up and automatic sign-in to the mobile browsers. So if any of that sounds appealing, especially mobile web user experiences, yeah, get in touch with us, and we'd love to hear how these things can help you and take feature requests and so on.
Perfect. We actually have one last question from Chetan. He'd like to know if we can see the demo.
The demo. Oh, okay. The demo's a little bit harder to do here on the Hangouts because we were going to actually just compile the Firebase code. So I'm not sure whether we can do it, but we can definitely get a recording of it for you. It's pretty simple. You would just include the Firebase library into your sample app, and then build it, and you'll have a pre-built authentication system out of the box. But that's actually Dev's demo, so I'm not sure if we don't have him, we might not be able to do it live here. But if you're interested, we'll certainly get you the
Perfect.
example.
Maybe we can get a recording and we can share it out then, Stephen.
Yeah.
Awesome. Excellent. If that's no more questions, thank you so much, Stephen, and everyone for joining us this morning. Hope all of you have a wonderful rest of your day. Thank you. Bye-bye.
Okay, thank you.